The ways in which we use technology will create and represent the ways by which we use them.
In this exclusive interview, we will explore CO2 battery technology with Paul Smith, Senior Vice President at Energy Dome. We'll discuss his journey from chemical engineering to leading the charge in renewable energy solutions. Paul, welcome to the Energy News interview series.
Thanks, Ernest. And I like the introduction, leading the charge. It does feel a bit like we're on the edge of something pretty big.
Can you tell us a little bit more about yourself?
Yeah, sure. So indeed, as you said, I'm a chemical engineer. I've got 30 years experience in the energy industry, and I did start in a rather conventional chemical engineering environment in BP in the UK before I moved to the Mediterranean. Lived and worked in this part of the world for the last 25 years now. So I'm based in Athens, working for Energy Dome, which is based in Milan, in Italy.
Can you tell me a little bit more about Energy Dome?
Yeah, so I mean, Energy Dome is a really, first of all, a great set of people with a vision to decarbonize the world with our CO2 battery technology. The company's 4 years old, only 4 years old, but I mean, the technology didn't just pop up overnight. The founder in particular, Claudio Spadaccini, the lead, has worked in the industry for 20 years, a couple of other important ventures in the past, one in biogas and the other one called Exergy, doing organic Rankine cycle technology, built a whole new concept of turbine technology for that particular application. So, you know, tremendous expertise in process engineering, turbo machinery, thermodynamics, all of these words which made you scared from engineering school. They know and love this stuff. Mechanical engineering, and all that came together to result in the idea of the CO2 battery, and then it's moved very, very quickly from there. So yeah, 4 years old, but already we're 60 people, growing very fast, and we're already present on 4 continents, actually, which is really, really quite remarkable.
Can you tell me, is there any connection to the hydrogen?
Yeah, absolutely. So a lot of the biggest projects we're talking about globally at the moment are, in fact, green hydrogen projects. And it may be power to ammonia, it may be e-methanol, it may be green steel. These are the projects that we see moving and with high chances to be realized. Of course, there's a very large number of very big projects. We're focusing on primarily projects which are actually, you know, doable over the next couple of years. They involve, for example, typically perhaps renewables, round-the-clock requirement for a process plant. So we're really the missing link to enable that to happen cost effectively, so we can provide a base load to whatever green ammonia production, e-methanol, green steel production, which are heavy energy consumers. The work we're doing on the actual electrolysis step is a little more complex because, you know, there are various ways of operating electrolyzers. You can allow it to a certain extent to follow the renewables production. And our relevance there is really triggered by the cost competitiveness of our energy storage. So when we get to a certain price point, it becomes much more it makes more sense to reduce the size of the electrolyzer and have an electrolyzer which is operating much closer to base load rather than load following renewables. So if we have a combination of very low cost renewables, which is going to be the case, and cost effective energy storage and relatively high cost of electrolyzers, it's going to make sense to have a lot of energy storage ahead of the electrolyzer. And otherwise, it would be more base load supply to the continuous operating process plant. So an ammonia plant, you can't start, stop, and load follow. You have to operate it on a steady, round-the-clock basis, and that's the kind of application. The same for green steel.
Can you give me your take on hydrogen in general?
Take on hydrogen. So that's a really big discussion. We are, big supporters, of course, because of anything which enables the energy transition, because we're part of that. Green hydrogen projects need our technology. So we will contribute, not all of them necessarily, but we're a big participant in several of these projects already. And then, the other dimension, apart from the power to X, is the power to power. So renewables, hydrogen and power. I'm not the only one who thinks that is not going to be the most economical way of generating power from renewables. So very skeptical on that. And we think energy storage, long duration energy storage, so renewables plus energy storage, just storing the electrons and delivering them back will make more sense than, in general, taking renewable electrons, making them into hydrogen and turning that back to electrons. The efficiency is very low. And that's a problem. And that results in expensive energy at the end of the day. What we want to do is deliver energy which is as cost effective or even more competitive than what we've been doing in the past. That's our mission.
Your CO2 battery promises a long duration energy storage without emissions. How confident are you that it can truly disrupt the traditional energy market?
Well, that's a great question, Ernest. And how confident are we? We are 100% confident. First, why are we 100% confident? We don't say this lightly. We understand this is a huge prospect, and it's a very important piece of technology. So the story is very simple. The technology is built entirely of standard industrial components. So the innovation is in the process. There are no new components or materials or anything in the plant which imply a technological risk. So supply chain is there. We're basing ourselves on very well established supply chain and components with decades of experience. So that's the one part. And then the other part is the performance and the cost. So in order to genuinely disrupt and contribute and be relevant in the market, it's no good just having a product which works and can be delivered. It needs to be not just competitive, but disruptively competitive. And where we are is that we have a product which has an efficiency of around 75%, which is, as far as mechanical energy storage technologies are concerned, extremely good, very similar to pumped hydro. And then on the cost side, this is where the most interesting part of the story is. So already on our first project that we're building, the first project, full-scale project, we're already at the cost level where we're far more competitive than lithium, and the trajectory is obviously extremely interesting as we scale up, and we already know pretty well what that's going to look like. So yes, yeah, are we complacent? No, it's going to be hard work, but it's not going to be limited by either the ability to deliver or the performance or the cost of the technology. Then it's about the ability of the industry to move fast enough and adopt new disruptive technologies like ours.
So you claim a cost advantage over existing solutions. Can you elaborate on the specific factors driving the cost competitiveness?
Yeah. I mean, it's very simple. Again, the cost competitiveness is about things like using standard components, which you can source quickly and cost effectively from existing suppliers, and it's about using standard materials. So we've designed the process in a way where the process conditions don't force us to start using costly materials. The whole plant is designed and built with carbon steel. So we're not into the range of stainless steel. That also makes it much more easy and fast to build. Welding regular carbon steel is a lot easier, and much more people are familiar with that than stainless steels. And then the materials, so everything is already out there in the market. Even the dome, which is by far the most unconventional part of the process, you will be amazed by how much of this material is out there in all kinds of different applications, including biogas, which is where the idea specifically comes from.
Long duration storage often struggles with scalability. How can your CO2 battery be scaled to meet the needs of large grids and industrial applications?
So we've taken a very, very specific approach to this, which is all about standardization of a very specific modular solution. So the plant that we're building now, which will be commissioned later this year, is a 20 megawatt, 10-hour energy storage plant. So we'll have 200 megawatt hours of energy storage and 20 megawatts of capacity to be delivered to the grid. And modularity is very simply copy paste of this at any scale. So comparing with other technologies, we don't need to build big turbines and big compressors, which actually, once you go beyond the size we're at, the number of options you have to actually source these kind of compressors becomes very limited. So we're at a sweet spot. We've selected a sweet spot, this 20 megawatts, 25 megawatts, where there are plenty of suppliers, experience, and the modularity is such you can install the unit quickly, and then you simply install many of these units. In the same way, if you want to build a 300 megawatt wind park, you buy a bunch of 5 megawatt wind turbines. You don't try and find two 150 megawatt wind turbines. Exactly the same idea.
What are the biggest technical challenges you currently tackle to optimize CO2 batteries' performance and efficiency?
We've had our demonstration plant, in operation. Actually, it was commissioned in May, June 2022. So we've had 18 months. There weren't really any surprises. I mean, in terms of process, this is not rocket science. I mean, a good engineer can model this and understand how it works very, very easily. You don't need to understand electrochemistry and how it degrades or not. The equipment will happily work as long as it's correctly maintained for 30 years, no degradation. So in terms of technical challenges, it's really been more about how do you productize this? how do you optimize the design of the plant, which we know works? How do you do it in a way which makes it highly deliverable and scalable, to go back to your question? And that's where the effort has been made. And again, no rocket science, but nevertheless, a huge amount of work. We've done all the engineering is done in-house. Tremendous depth of experience there. Selection of things like how do you do the thermal energy storage, but again, it's more about innovative process engineering rather than finding complex or unusual ways of doing things and having to prove it works.
How have you addressed the concerns of safety?
Yeah, so safety, good point. The only significant safety issue on a plant like ours, well, first of all, you have the usual kind of safety issues associated with electrical high voltage equipment, medium voltage in our case equipment, safe working practices. So first line of defense is safe working practices, which have to apply anywhere. In terms of other hazards, the only significant one, which not so significant really, is the CO2, the volume of CO2 that we actually have in the plant. So we have about 2,500 tons of CO2 in the plant, and the only concern is suffocation risk. So if you have a major breach, what happens with that CO2 and how do you deal with that? So that's addressed with detection instruments around the plant and a gas dispersion study. And it turns out that if you do get a leak, which is a very remote possibility, you would simply, the gas would simply disperse after a certain number of meters away from the dome or the high pressure site. So there's no significant risk, and all of that is addressed in any case in the environmental permitting of a unit.
How do you differentiate your CO2 battery from other long duration storage solutions?
Yeah, I mean, in a way, it differentiates itself because it, first of all, looks very different. I mean, how do we differentiate it? I mean, there's a tremendous range of other technologies, as you know. I think the really key differentiator for us is the fact that we're really genuinely ready for market now. So the real differentiator, and we're pushing this, you'll see our website, as the only real deliverable alternative. So the alternative, of course, to lithium batteries. And that's the key differentiator, that you've got something where the supply chain is there, the technology is proven, and it's all about now how do we actually bring this to market quickly enough and at scale to really make a difference. But again, to go back to the earlier point, it's not limited by the supply chain or the readiness of the technology. It's all about how do we get this into the market, and that we're depending on the viewers of this interview to take on their part of the story and bring it through development into the real world.
To support the last statement with the next question, are there any strategic partnerships or investments crucial for commercializing your CO2 battery?
In a way, yes. We're going to need to have a lot of commercial partnerships, no doubt, in many parts of the world. We will not be delivering all of these units ourselves into the market. I mean, it's all about partnering with utilities, with industrial off-takers. So yeah, there is a tremendous world of partnership to be developed around this. I mean, just to give one example, one of the partnerships, one of the important partnerships we've entered into recently is with MAN Energy Solutions, who are delivering the turbine for our first unit. They're also able to deliver the compressor, so they can provide a complete turbo machinery solution for this kind of projects. And we're talking with them obviously about a much broader cooperation and already building up technological collaboration on the R&D side and looking at specific markets around the world with them. Just an example, and then we don't have enough time really to talk about the kind of breadth and scope of the other cooperations we're developing, but they're very significant in many of the large markets of the world.
When do you expect the first large-scale deployments of your battery technology?
Well, first of all, the first deployment will be later this year. And that is, when we say large scale, it's 20 megawatts. That proves that the full scale solution can work. And then from there, it's a question of rolling out that same solution everywhere. So in the US, we together with Alliant Energy in Wisconsin, who were awarded a Department of Energy grant for a CO2 battery project, they will implement and deploy a project which is practically the same as the one that we're building now in Italy. The main difference is being that that would have a gearbox and slightly different electrical equipment because it's 60 hertz, not 50 hertz. But otherwise, it would be the same. And the same applies, for example, in India, in Australia, slight adaptations to accommodate whatever local standards there are. And then the standard solution will be deployed at scale.
How are you working with regulators to ensure a smooth adoption of your technology within existing energy frameworks?
Yeah, well, we have a certain limited bandwidth. It's not feasible for us at this stage to really convince all the energy regulators around the world to adapt their current policy framework to accommodate long duration energy storage, because what's needed is I don't think the long duration energy storage community as a whole would request or need technology specific support. It's really about what kind of policy frameworks are necessary in order to enable this kind of large scale, effectively infrastructure investment. It requires a long-term support. These are projects with 20, 25, 30-year lifetimes plus. So you need a policy framework which is adequate to support those kind of things, those kind of investments. I have to say that we're part of the Long Duration Energy Storage Council, which is a really active body representing both technology suppliers and many potential users of this kind of technology. So they're doing a great job advocating around the world. Next week, we'll be in London at the Energy Storage Summit. We'll be speaking on a panel with the Department of Energy Security and Net Zero of the British government, and contributing to the debate there. They've recently released a consultation paper on a cap and floor mechanism to enable long duration energy storage investments. So there's a lot going on. There's only a certain amount we can actually do ourselves. We do hope that regulators and government pick this up quickly, because there are some important adjustments needed to enable this to happen.
What are your plans for expanding your technology beyond the initial targeted markets?
I think the targeted markets are pretty big enough. The the market for energy storage is terawatt plus. That's 1,000 gigawatts, and that's the power capacity. That's not the energy storage capacity. So, you know, just looking at specific countries, such as I just mentioned, the UK, where my original home, where in this consultation, some work has been done on modeling the system requirements, and they're talking about 30 gigawatt requirement for longer duration storage. The same in Spain. They've also done a study, it's 20 gigawatts plus. And then you can kind of repeat that across Europe and then the rest of the world, and you can see how that reaches quite a big number. We think it could be much bigger, actually. And partly that's triggered by how competitive energy storage is to other forms of other ways of enabling decarbonization.
Does this technology have potential applications beyond grid-scale energy storage, such as microgrids or industrial power needs?
Microgrids, almost certainly not, because this is a large-scale solution. It lends itself much better to scaling up rather than scaling down. So our demonstration project is 2.5 megawatts. This is not the kind of thing. It's that kind of market would probably be best served by the even more granular modularity of electrochemical technologies. And then industrial, of course, there's a large element of heat decarbonization. That's not something that we're currently targeting, because our product is efficient enough already that we really don't need to integrate with heat processes in order to achieve the efficiency you need to be competitive. And there are other technologies which are targeting heat specifically, as you know, and others which are targeting both electricity and heat. We're all about electricity and large-scale decarbonization of electricity. We'll see what happens later, because the technology does have various dimensions which could be exploited on heat integration. But that's not a current focus at all.
Can you quantify the potential environmental benefits of this technology compared to traditional solutions?
Yeah. So environmental benefits. I think if you look at the life cycle of a project like this, let's just break it down a little bit. We have the product itself. What does it consist of? We have a lot of steel in the plant, which is, you know, eminently recyclable. It's not a heavy environmental impact, or as a heavy environmental impact as you know, let's take things like cobalt and other forms of mining activity. Green steel is coming along, and we're actually very much engaged with one or two green steel projects in terms of looking at how we can deliver around the clock power solution for those green steel projects. But we're very pleased to see green steel happening, because we expect to be using it as well in the future. So that's one aspect in terms of the materials. And then I think the other critical thing to understand, this is extremely important, it's a 30-year plus technology. So it's not something you need to replace through the lifetime of the project, again, with all of the environmental impact associated with that. So the carbon footprint of the technology is very low. And of course, we're using some CO2 usefully for 30 years as well, which is even better.
What exciting future innovations are you envisioning for the CO2 battery technology and its role in the clean energy solution and transition?
Yeah, so we have we've got two things going on. I mean, first of all, the most important part and the most important message I think today is that we already have a very highly optimized scalable solution for this energy storage applications without any further development of the technology. In the future, I think we know what our current efforts are directed towards are how we can actually optimize the deliverability of this technology for a gigascale projects. So, I mean, this can include things like a larger dome. So a dome which serves multiple units, for example. It's those kind of the regular engineering stuff that you do to figure out what is the best way to deliver a large scale project. So we're doing a lot of that. And then on the R&D side, I don't want to give any clues, but we've got a brilliant set of guys led by my colleague Dario, our Chief Technology Officer, who I don't know where he gets his ideas from, but most of them are brilliant.
What do you see as the biggest challenge and opportunity for Energy Dome in the next 5 years?
I think the biggest challenge is, I think the biggest challenge is going to be how can we keep up with the demand? So we're not actually at the stage yet where it's easy to understand how fast this can actually grow. But when I say keep up with the demand, I mean there is always going to be in any organization a certain bandwidth and the same in our clients. So we do need to keep growing, and we need to keep our eyes on the ball in terms of deliverability, making sure we're executing on what we're saying. So we're extremely conscious of that. And then the other challenge is the industry and our clients really moving fast enough to decarbonize? Are they jumping? Are they taking some educated risks on bets on technologies, getting ahead of the ball? Because there are far too many fast followers. In order for there to be fast followers, we actually need some clients who are actually taking a bet on a new technology, and they're going to be the big winners. We think the early adopters of this are going to have a tremendous advantage over other forms of energy storage, we believe.
What ultimate dream do you have for Energy Dome, and what impact do you want to make on the world with your technology?
Well, the vision, and I have to say this is our founder, Claudio, is that we want the dome to be one of the symbols of the successful energy transition. And that's a pretty big vision. But why not? We think it's absolutely deliverable and makes total sense.
Paul, thank you for being my guest today.
Thanks a lot, Aaron. It's great to speak to you. Thanks so much for all the great questions.